Hello, greetings. So for this lesson, we shall study rocks. Now, if you will recall in our previous lesson about minerals, we know that minerals may combine to form rocks. Now, let's take this as an example. So we have here granite. Now, granite as a piece of rock may be composed of the following minerals. So we have mica, feldspar, and quartz. So this piece of rock called granite may be composed of several minerals. Now, to give you the proper perspective of what a rock really is, we have to take note that rocks are made up of elements, and these elements may combine to form minerals, and minerals may combine to form rocks. So let's define now what a rock really is. So, what is a rock? Now, a rock is a mixture of such minerals like feldspar or mica or quartz in the case of granite. Or a rock may be a mixture of rock fragments, volcanic glass, organic matter, or other natural materials. Now, most rocks used for building stone contains one or more common minerals, and they are called rock-forming minerals. So examples of these rock-forming minerals are the following. So we have quartz, feldspar, mica, or calcite. Like in the case of granite, granite may be composed of feldspar, mica, and quartz. And also, when you look closely on a piece of rock like the one in the picture, the sparkles that you see are those individual crystals of minerals. Now, before we go into the details of this lesson about rocks, let's first differentiate between minerals from rocks. Now, what are the differences between a rock from a mineral? Now, we have to take note that minerals are solids. There is no such thing as a liquid mineral. Minerals are also naturally occurring. So you have to take note, there is no such thing as a man-made mineral. Minerals are also inorganic. They have a fixed composition, and they are made up of one or more elements. Now, what about rocks? Rocks are made up of one or more minerals. Now, to further differentiate between a rock from a mineral, let's take a look at this flowchart. Okay, so let's first enumerate the similarities between rocks and minerals. So both rocks and minerals, they are made up of elements. Both rocks and minerals are solid in form. Both rocks and minerals, they can be made of lava or magma. They have crystals in them, and both minerals and rocks, they can be formed from solutions. Now, what about the differences between minerals and rocks? So minerals are inorganic. They must be inorganic. Again, there is no such thing as an organic mineral. So minerals must be inorganic, and they can be made of compounds, and minerals are naturally occurring. So there is no such thing as a man-made mineral. Now, rocks, on the other hand, they can be made from organic materials. They are mixtures made of minerals, and rocks can be man-made. So those are the differences between a rock from a mineral. Now, what are the different types of rocks? Now, there are three types of rocks. So first, we have igneous rock like this obsidian. Then we have sedimentary rock like this red sandstone. And we have metamorphic rock like this white marble. Now, all of these three types of rocks, they undergo what we call as the rock cycle. Now, what is this so-called rock cycle? Now, the rock cycle shows how rocks slowly change through time. And scientists, they have created this model which we now call as the rock cycle. The rock cycle illustrates the processes that created and changed these rocks. And the rock cycle shows the three types of rocks: igneous, metamorphic, and sedimentary rocks, and the processes that formed them. So to further explain the rock cycle and the formation of the three types of rocks, let's take a look at this diagram. So this diagram will further explain how these three types of rocks are formed and the natural processes involved. Now let's start first with igneous rocks. Now, when igneous rocks are subjected to pressure and heat, igneous rocks are converted into metamorphic rocks. And when metamorphic rocks are subjected to weathering and erosion by, say, running water, metamorphic rocks are converted into sedimentary rocks. And when sedimentary rocks are subjected to melting in the formation of magma, and when that magma cools and crystallizes, sedimentary rocks are converted into igneous rocks. And you would see crisscrossing arrows. So what does that mean? It means that when, say, igneous rocks undergo weathering and erosion by running water, igneous rocks can be converted into sedimentary rocks. Or sedimentary rocks are subjected to pressure and heat. Sedimentary rocks can be converted into metamorphic rocks. And when metamorphic rocks are subjected to melting in the formation of magma, and when that magma cools and crystallizes, metamorphic rocks can be converted into igneous rocks. So that's the rock cycle. The rock cycle shows how the three rock types are formed and the processes that are involved. Now, isn't that fascinating about the rock cycle, the formation of the three rock types and the processes that are involved in their formation? So let's take a look again at this diagram to further again explain the rock cycle. Now, when igneous rocks are subjected to weathering and erosion by running water, igneous rocks, they form sediments. And when these sediments are deposited and they are compacted, they form sedimentary rocks. And when sedimentary rocks are subjected to heat and pressure, these sedimentary rocks are converted into metamorphic rocks. And when metamorphic rocks are subjected to melting in the formation of magma, and when magma cools and crystallizes, metamorphic rocks are converted into igneous rocks. So you will notice that rocks are neither created nor destroyed. Rocks are simply converted from one form to another. Okay, so when igneous rocks are subjected to weathering and erosion, they are converted into sedimentary rocks. And when sedimentary rocks are subjected to heat and pressure, they are converted into metamorphic rocks. So rocks are neither created nor destroyed. Rocks are simply converted from one form to another. And this is what we call the conservation of matter. So the law of conservation of matter jives with the rock cycle. that matter cannot be created nor destroyed. The changes that take place in the rock cycle never destroy or create matter. The elements are just redistributed in other forms. So as a conclusion, the rock cycle follows and jives with the law of conservation of matter, that rocks cannot be created nor destroyed. Rocks are converted from one form to another, and this will allow the redistribution of elements. So before we move on with the classification of rocks, let's watch this fascinating video about the rock cycle. So let's watch this.
Hi, my name is Thor Robertson. Today I'm going to be teaching you about the rock cycle. First, you need to know about the three different types of rocks: igneous, sedimentary, metamorphic. Each of these rocks has a unique way of forming and can even transform into one another. Now, let's start by explaining how igneous rocks form. This volcano looks like it's about to erupt. Beneath the Earth's crust is liquid magma. Magma usually travels to the Earth's surface through volcanoes. Once the liquid hot magma makes its way above ground, it cools and hardens over time into new rock. These rocks that form are what we know as igneous rocks. Sedimentary and metamorphic rocks can become igneous rocks by melting and hardening, although this is a very rare occurrence. Now, let's move on to sedimentary rocks. Sedimentary rocks are easy to identify because of their name. Sedimentary rocks are composed of loose sediments, hence the name. Parts of igneous and metamorphic rocks can become sedimentary rocks through weathering, erosion, compaction, and cementation. Weathering and erosion are natural forces that cause pieces of rocks to break off into smaller sediments. This is usually caused by wind or the water. These sediments then get carried away and gather over time, as you can see here. This is called deposition. Now, compaction and cementation binds these sediments together with pressure and other earth elements, specifically water. The rocks that form are what we know as sedimentary rocks. Finally, let's discuss metamorphic rocks. Metamorphic rocks form from a process, similarly called metamorphosis. Metamorphosis occurs when other rocks are subject to intense heat and pressure. Let's take a look. Underground, magma can find its way through porous and loose materials. When the magma can't get to the surface, it starts to change the sediments and materials that are close enough to feel its heat. The heat from the magma and the pressure from the tons of material above cause the surrounding sediments and materials to change their composition and structure. Metamorphosis usually occurs at temperatures between 300 and 700 degrees Celsius. These new rocks that form are what we know as metamorphic rock. Igneous and sedimentary rocks can go through metamorphosis if they are buried deep enough under the Earth's surface and if they are exposed to high enough temperatures. Let's get back to my office now. As you can see, rocks form in many ways, and each rock has the potential to become a different kind of rock under the right circumstances. The rock cycle has existed for as long as we can date back. Rocks have been forming and transforming for millions of years. The Earth is made of rocks, and now you know how they form. Thanks for watching. I'm Thor Robertson.
Alright, so I hope everything is clear about the rock cycle and the processes that are involved in the formation of the three types of rocks. Now let us proceed into a more detailed discussion of the classification of rocks. Now, rocks are classified according to the following. Number 1, by how they are formed. Number 2, their composition. And number 3, texture. And we know for a fact that rocks change over time through the rock cycle. So there are three types of rocks that we mentioned a while ago. So we have igneous rocks, sedimentary rocks, and metamorphic rocks. So let us now go into the details of our discussion. Let us now zoom in on igneous rocks. Now, when we speak of igneous rocks are formed from volcanic activity. And igneous rocks, they begin as magma. Igneous rocks begin as magma, and magma can form through the following ways. Number one, magma can form when rock is heated. Number two, magma can form when pressure is released. And number three, magma can form when the rock changes its composition. And when magma freezes, it freezes between 700 degrees Celsius up to 1250 degrees Celsius. Now, when we speak of magma freezing, it simply means that magma cools and hardens. And when magma cools and hardens, it forms into igneous rock. So that's how igneous rocks are formed. Igneous rocks, they begin as magma. And when that magma erupts from a volcano, that magma cools and hardens, and eventually it forms into igneous rocks. Now, there are two types of igneous rocks. Igneous rocks can be extrusive or intrusive igneous rocks. Now, what are extrusive igneous rocks? Now, when we speak of extrusive igneous rocks, these are rocks that are formed from the solidification of lava on or above the surface. And there is rapid cooling from exposure to air or water, resulting in rapid crystallization of their component minerals. Now, because of this rapid cooling, there is no time for these minerals to form crystals. That's why extrusive igneous rocks, they usually exhibit a fine-grained texture. So to put it simply, pag ang magma ay lumabas sa isang volcano, ang tawag po natin sa magma na yan ay lava. Now, itong lava na ito is exposed to air or water. And ang resulta nito ay rapid cooling. Mabilis po siyang lumamig if that lava is exposed to air or water. Now, because of this rapid cooling, dahil mabilis pong lumamig ang extrusive igneous rocks, wala pong time para makrystallize yung mga minerals na nasa loob ng lava na yan. Okay, that's why extrusive igneous rocks, they usually exhibit a fine-grained texture. So, medyo makinis po yung surface ng extrusive igneous rocks. Because of this rapid cooling, mabilis pong lumamig, there is no time for the minerals to form crystals. Okay? So, when magma moves out from a volcano, you call it lava. And that lava is exposed to air or water, resulting in rapid cooling. And this rapid cooling means that there is no time for the minerals to form crystals. That's why extrusive igneous rocks, usually they exhibit a fine-grained texture. So that's how extrusive igneous rocks are formed. Extrusive igneous rocks, they begin as magma. And when that magma erupts from a volcano, we call that lava. And when that lava cools and hardens, it forms extrusive igneous rocks. Now, since the lava is exposed to air and water, there is rapid cooling. And what is the implication of this? This rapid cooling will affect the crystallization of the minerals in the magma. Since there is no time for the minerals to crystallize because of this rapid cooling, the extrusive igneous rocks would exhibit a fine-grained texture. Now, what about intrusive igneous rocks? Now, when we speak of intrusive igneous rocks, these are rocks that are formed by the crystallization of magma at a depth within the earth. And intrusive igneous rocks are characterized by large crystal sizes. So in terms of texture, we call that coarse-grained. Their visual appearance shows individual crystals interlock together to form the rock mass. Now, what causes these large crystal sizes? Now, this is due to slow cooling. The cooling of magma deep in the earth is typically much slower than the cooling process at the surface. And the implication of that would be larger crystals can form. So to put it simply, if magma never erupts and cools slowly inside the volcano, then eventually that magma becomes an intrusive igneous rock. Okay, so again, when we speak of extrusive igneous rock, you have magma that exits through the volcano and we call that lava. Lava comes into contact with the air and water. Eventually, that lava cools and hardens and forms extrusive igneous rocks. While, on the other hand, if the magma never erupts and stays inside the volcano, then that magma will eventually turn into intrusive igneous rock. Now, we have to consider also the degree of cooling. Now, in the case of extrusive igneous rocks cool quickly, and as a result, these rocks are fine-grained or they lack crystal growth, while intrusive igneous rocks are formed from magma that cools slowly, and as a result, these rocks are coarse-grained because of the rapid growth of crystals. So I hope everything is clear about the differences between extrusive and intrusive igneous rocks. So again, when magma exits through a volcano and we call that lava, lava eventually comes into contact with air and water. Eventually, that lava cools quickly and forms extrusive igneous rocks. Now, because of this rapid cooling, there is not enough time for the minerals to crystallize. That's why extrusive igneous rocks are fine-grained in terms of texture. While if magma doesn't erupt and stays inside the volcano, there is slow cooling. And this slow cooling of magma inside the volcano will eventually turn into intrusive igneous rocks. Now, the minerals will have enough time to crystallize. That's why intrusive igneous rocks are coarse-grained in terms of texture because of the formation of large crystals due to the slow cooling process. Now, the following are examples of extrusive and intrusive igneous rocks. Now, under extrusive igneous rocks, we have the following examples. So we have basalt, andesite, dacite, and rhyolite. Now, under intrusive igneous rocks, we have the following like gabbro, diorite, granodiorite, and granite. So those are examples of extrusive and intrusive igneous rocks. And we have here pictures of extrusive and intrusive igneous rocks. So under extrusive, we have basalt, andesite, and rhyolite. And under intrusive, we have diorite, gabbro, and granite. Now, everybody, I want you to zoom in on the texture of extrusive and intrusive igneous rocks. Now, everybody look at basalt, rhyolite, and andesite. So they exhibit a fine-grained texture. Extrusive igneous rocks, they exhibit a fine-grained texture, again because of rapid cooling. This rapid cooling will minimize the formation of crystals, and as a result, the rock would exhibit a fine-grained texture. Now, for intrusive igneous rocks, everybody look at diorite, granite, and gabbro. So you can see large crystals. So diorite, granite, and gabbro, they exhibit a coarse-grained texture, again because of slow cooling. The slow cooling process will allow the formation of large crystals. Hence, the texture of these rocks would be coarse-grained. So at this point, let us consider other terms that are related to the classification of igneous rocks. So we have terms such as felsic. So when you say felsic, these are light-colored igneous rocks that are rich in elements like aluminum, potassium, silicon, and sodium. And we also have the term mafic. So when you say mafic, these are dark-colored igneous rocks that are rich in calcium, iron, and magnesium, but poor in silicon. Plus, we have our usual terms such as coarse-grained. So when you say coarse-grained, it takes longer to cool, giving the minerals, crystals more time to grow. And we have fine-grained. When you say fine-grained, these are rocks that cool quickly with little to no crystals at all. So, in classifying igneous rocks, we have to consider whether the igneous rock is felsic or light-colored, or mafic or dark-colored. Or in terms of texture, we have to consider whether the igneous rock is coarse-grained or fine-grained. Now, everybody, let's take a look at the following igneous rocks. So we have granite, rhyolite, gabbro, and basalt. Now, in terms of the coloration, look at granite and rhyolite. Both granite and rhyolite are light-colored igneous rocks. So we can classify them as felsic. Now, look at gabbro and basalt. Now, both gabbro and basalt, these are dark-colored igneous rocks. So we can classify them as mafic. Now, what about texture? Everybody look at granite and gabbro. So you will notice the large crystals inside granite and gabbro. So that makes them coarse-grained. While look at rhyolite and basalt, they have little crystals in them. So that makes them fine-grained. So that's how we classify igneous rocks, whether they are felsic or mafic, coarse-grained, or fine-grained. Now, at this point, let us consider some examples of igneous rocks, starting with obsidian. Now, obsidian is a dark-colored volcanic glass that forms from the very rapid cooling of molten rock material. It cools so rapidly that crystals do not form. Okay, so at this point, let us now classify obsidian. Now, is obsidian felsic or mafic? Now, what do you think? Now, if you answered mafic, then you are correct. Now, look at obsidian. Obsidian is a dark-colored igneous rock. So, that is mafic. Now, everybody look at obsidian again. Is obsidian fine-grained or coarse-grained? Now, what do you think? Now, if you answered fine-grained, then you are correct. Obsidian is fine-grained because of its rapid cooling. And rapid cooling means that there is no time for crystals to form. So obsidian is a fine-grained igneous rock. Now, is obsidian intrusive or extrusive? So what do you think? Now, if you answered extrusive, then you are correct because of the rapid cooling of this molten rock material. So obsidian is mafic, fine-grained, and extrusive igneous rock.
Igneous rocks. Objective: to learn about igneous rocks, their types, and formation. The Earth's crust is made up of different types of rocks. The rocks which make up the maximum volume of the Earth's crust are called igneous rocks. The word igneous has been derived from the Latin word ignis, which means fire. These rocks are associated with volcanic eruptions. Let's study more about igneous rocks and how they are formed. The liquid rock matter that we see coming out from volcanoes is called magma. It is a hot liquid made of melted minerals. When this magma reaches the Earth's surface, it is known as lava. The cooling and the solidification of lava at the Earth's surface result in the formation of extrusive igneous rocks, which are also known as volcanic rocks. Due to rapid cooling, their crystals are fine-grained. However, some of the magma can't come out and settles inside the surface. The magma cools slowly beneath the Earth's surface as it is completely surrounded by the soil and rock present there. The cooling and the solidification of magma at a depth within the Earth's crust result in the formation of rocks having large crystals, known as intrusive igneous rocks. So we have learned that igneous rocks are of two types: extrusive igneous rocks and intrusive igneous rocks. It is interesting to know that igneous rocks were the first to be formed and are also known as primary rocks. Pumice and obsidian are extrusive igneous rocks. Pumice is used in making lightweight concrete, and obsidian is used in ornaments. Granite and diorite are intrusive igneous rocks. Both are used as building material. To summarize, igneous rocks are of two types: extrusive igneous rocks and intrusive igneous rocks. The cooling and the solidification of lava at the Earth's surface result in the formation of extrusive igneous rocks. They are also known as volcanic rocks. The cooling and the solidification of magma at a depth within the Earth's crust result in the formation of intrusive igneous rocks.
Welcome to Moo Moo Math and Science. In this video, I'd like to talk about igneous rocks, and I'll include the difference between mafic igneous rocks and felsic igneous rocks. Igneous rocks are created from molten rock. In fact, the name is derived from a Greek word for fire. Igneous rocks form from hot molten rock that cools and then solidifies. Igneous rocks may form from magma, which is found inside the earth, or lava, which is molten rock on the surface of the earth. There are two major types of igneous rocks, intrusive and extrusive. Let's take a look at how intrusive and extrusive rocks differ in terms of what they form from, where they are created, the rate of cooling, the size of crystals, and the texture. Extrusive igneous rocks are created from lava. Lava is molten rock found on the surface. Intrusive rocks are created from magma, which is molten rock found inside the earth. Extrusive rocks are created on the surface where molten rock has flowed. Intrusive rocks are created inside the earth from hot magma. Extrusive rocks cool quickly. Intrusive rocks cool slowly. They're inside the earth, which acts a little bit like an oven, which slows the rate of cooling. Extrusive rocks may have really small crystals, smaller than 1 millimeter, or no crystals at all. Sometimes they may either be vesicular, which means the rock may have air bubbles. Intrusive rocks have crystals larger than 1 millimeter. Take a look at these intrusive rocks and their crystals. Extrusive rocks have a very fine texture. Some, like obsidian, may even be smooth. Intrusive rocks have a coarse texture, which can be described as rough. Because intrusive rocks have larger crystals, this makes their texture rough. See if you can tell if the following rocks are extrusive or intrusive. Another way that you can classify igneous rocks is to determine if the rock is mafic or felsic. Classifying as mafic or felsic is actually a scale of the percent of silica found in the rock. 0 to 45% is considered mafic, and 65% or greater of silica is felsic. 45 to 65% is considered intermediate. Mafic rocks are dark in color, and felsic rocks are lighter in color. The names give you a clue as to what other minerals make up these rocks. Mafic can be broken down into Ma for magnesium, and then Fic, which is Latin for iron. Felsic can be broken down into Fel for feldspar, and Sic for silica. Let's take a look at some mafic and felsic igneous rocks.